So let's continue on with the second part of the overview for my Scalable Microservices course. Here we're going to talk about the assignments and assessments for the course. So the programming assignments are all written in modern Java using IntelliJ. You're welcome to use other IDEs if you so desire. For some reason you want to use Eclipse, or if you want to use NetBeans or something else. However, your final submission must build and run with the latest version of IntelliJ as well as Java 19. Now, it's probably possible to use Java 20, but I know for sure that Java 19 works, and we'll talk about the differences in a moment. You can download the Java 19 runtime environment using the IntelliJ IDE. There's some instructions on how to do that here in the wiki page on CS2891's repository and my GitHub account. And effectively, you'll basically go in there and it'll prompt you. I think I have some more discussion about how to do this in a second. But basically, you can pick which version of Java that you want to use. And if you use Java 19, I think you need to use the Gradle version 7.6, but that should hopefully set itself up automatically. All the source code for the assignments is available in my GitHub repository, which we went over, where you can find that. It's linked in the Piazza page, and you'll see the first assignment is already up, assignment 1A. If you don't know how to use GitLab, the very first thing you'll need to do is get that set up. Most people I've found are able to use it because they've used it in other courses. If you've taken my course before, you've learned how to use GitLab. But very important, if you don't know how to use GitLab, please contact Skylar. He can walk you through it. It's not really that hard, but there's a couple things you got to remember how to do. Most notably, you need to make sure that you set up your SSH key correctly. We'll talk through the details of this in just a bit. There may be some times when you need to update your repositories. Oftentimes, not oftentimes, very infrequently, I'll detect there's a bug in the skeleton code I put out or the test cases. So you might need to learn how to update stuff. Shouldn't be that hard to do, but it's something you need to be aware of. And mastering how to use Git and GitLab and GitHub, while painful and frustrating at times, is quite a valuable skill to have because it's very, very widely used in industry. The assignments that we're going to cover here will give you a range of experience with modern Java concurrent and parallel microservices. In particular, we're going to implement a microservice-based movie recommendation system using both Spring Web MVC as well as Spring Web Flux, using all kinds of interesting modern Java features. So we'll be using Lambda expressions and method references and functional interfaces. That's part of the modern Java functional features that were added in 2013, starting in Java 8. We'll also be focusing on Java sequential streams, Java structured concurrency, Java reactive streams, as well as Spring Web MVC and Web Flux. The Web Flux features will be figuring prominently when we do reactive streams. We'll be doing Spring Web MVC features with sequential streams and structured concurrency. The topics covered by the assignments might change a tad, but I'm pretty confident these are what we're going to cover unless something really unusual happens. Now, the way that we actually do the assessment is kind of interesting. If you've taken my courses before, you know how this works. If you haven't, this is a little different from the way that many other courses work at Vanderbilt. And I think it's very good. Most people, when I get evaluations at the end of the semester, people really like the way that this works. So first thing to note, there's going to be a multi-phase submission process for each assignment, where the first phase, as we'll see in a moment, involves you providing an initial submission. It's very, very, very important that you submit your assignments on time and that you also submit them correctly. And that means filling out the Google submission form that we'll talk about in a moment. And if you don't do that, your code will not be reviewed. No exceptions, end of story. I will mention this a couple times, but I'm really a stickler about this because it's absolutely imperative that you follow these instructions, since it requires a lot of work on my part and the TA's part to do things this way. So if people start trying to submit stuff after the deadline, it gets very chaotic. So this is basically how things work at a high level. So each assignment will be due with an initial submission, and you submit your program, and I will review your code myself, and I will provide you with feedback, and I'll push that feedback back to your GitLab repository. That's why it's important for you to make sure that you make me and the TAs maintainers so that we can push code to your account. You then get some amount of time, a few days, maybe a week at most, to revise your program. Then you resubmit it, push it back to your GitHub, your GitLab account, and then the TAs and graders will review your code and grade it and assign you with the final grade. So that's the way it works. Some of the assignments have multiple parts, in which case your final grade will be given on the final part of that assignment. So for example, assignment 1 has part A and part B. You'll have this iterative process for each of those parts, and then your final grade will be taken on assignment 1B when you've had a chance to revise everything. Now, a couple things to note. First, your initial submission must be relatively complete, and it must compile. If it doesn't compile and there's lots of things missing, it's not going to be reviewed. So this is meant to ensure people are keeping up with the course and not waiting to the last minute to do the work. But you can't just sort of provide some hacked up solution and expect us to spend a lot of time reviewing it. That's just not going to happen. Now, the other thing that we're going to do here that's pretty cool, and we started this last semester and it worked out quite well, and Skylar has become the expert on this, is we actually use ChatGPT to automate some of the steps in reviewing your solutions. And this is something called discrepancy analysis, which is a really cool technique that's going to take the world by storm here very quickly if it hasn't already. So here's what happens. I start out by looking at all your code and providing you with individual customized feedback. And then I collect all of the problems I see and I put them into a file, and I make a video that I call the frequently made mistakes video, or the FMM video. And this video will walk through all the problems I saw and kind of explain why they're problems, maybe give a few hints at what you need to do to fix the problems. Now, what was interesting was historically, I've been doing this for a very, very long time, decades. But the problem was, in the past, when I would compile these lists of frequently made mistakes, I couldn't really leverage this knowledge between course offerings because every semester I'd have to start over again. So what we're doing now is we're using the frequently made mistakes analysis in order to generate a rubric that we can then feed to ChatGPT in order to help to automate subsequent steps in the grading process. So from the frequently made mistakes video, we run a script that makes a rubric of common mistakes, keeping track of what the problem was, what the incorrect way of doing things were, what the correct way of doing things are, and so on. And then when we get to the final phase where you resubmit your revised solution addressing the comments that I provided in the frequently made mistakes video and in your code, the TAs and graders no longer have to read my mind to evaluate the student final submissions in a consistent way. And instead, what we do is we train ChatGPT to analyze the final submissions and look for instances of these frequently made mistakes. And it's really very cool. You can take a look at a paper that we wrote at the bottom here that goes through the process and describes why this is a win. But I'm very excited about this, and we made a lot of progress to automate stuff. So the good news is people should get very precise and detailed feedback on their code at multiple levels throughout the process. Now, what we do, of course, is the ChatGPT is not giving you the grade. It's identifying areas that may be discrepancies with respect to the right solution. And we use a private version of ChatGPT to do this so that your code doesn't leak to the outside world, and make ChatGPT trainable on our core solutions. We don't want to do that. And if there are problems, because this is still generative AI is not 100% correct, the good news is we spot check it, the TA spot check it, so there should be no mistakes that leak through. But of course, make sure you take a look at the code that you get back and the final grade and the errors that it identifies. And if you run into any problems, let us know, and we'll be happy to address them. So kind of a cool thing. This is a good example of using large language models and generative AI to help automate the process of assessment in computer science courses, which is very helpful. Now, something else that you absolutely have to get in the habit of doing, and I'll talk about this more later, there's a set of automated regression tests, and you need to make sure that your code passes those regression tests. And you also need to take a screenshot of the results when you run the tests and put those results at a top-level directory in your solution folder that you push to your GitLab repository. And that way, when I review your code, I can see at a glance where you might be having problems. And that helps me focus my efforts more precisely to give you feedback that will actually be helpful. Very, very, very important to do this. Something else that's important, I'll mention this, but the work that you do here must be your own. This is not a projects course, so everybody has to do their own programming assignments. And the same thing holds for quizzes and exams and other things that we do. The bulk of your grade will be based on the results of automated unit tests that we provide. And we have quite a number of tests. By the time you're done with the final assignment, I think there's going to be probably hundreds of tests that get run, which is very helpful because it should always give you a sense of where you are in terms of whether you're succeeding or failing at meeting the requirements of the program. Now, this is super important, maybe the most important thing to remember. And so I'm going to say it now and I'll remind you, but you are also 100% responsible for remembering to do this. When we put out new versions of the assignments, we sometimes improve the unit tests for the previous versions of the assignments. And therefore, it's important that all your assignments pass all the unit tests for the current assignment and the previous assignments. And you should know this because when you run your code, you'll be able to see whether or not you get green check marks, which means everything worked, or yellow or red check marks, which means that there are problems. If you get yellow and red check marks, you're responsible for fixing them, even if they're on parts of the assignments that you did earlier, because we may have changed the tests. So really, really, really important to do this. Every semester, people forget to do this, and they lose major points, and they're very upset. And I'm just saying now, this is your responsibility to make sure that you do this. I will try to remind people each time, but make sure that you follow the instructions and always run all the tests and try to get all your tests to pass when you submit it initially. Of course, it may not be possible because sometimes it's a little tricky. That's what the review process is for. But make sure when you submit your final version, everything is as green as you possibly can. Get it, otherwise you lose points. And if you take a look at the GitHub wiki here, you'll see that items number 15 and number 19 talk about this in detail. So make sure you follow those instructions. Here's the relative weighting of each portion of the course: 45% for quizzes, 40% for programming projects, 10% for a final exam, if we have one, and 5% for participation. If we don't have a final exam, we'll split the final exam points between the quizzes and the programming projects. So quizzes will be worth 50%, programming projects will be worth 45%. What is the 5% for participation? There are three pieces to participation: attending class, being involved in class, and perhaps most importantly, especially this semester, following directions. So what does following directions mean? Following directions means things like making sure that you submit the Google form that indicates where to find your code and that you've actually got your code done. If you don't do this, your code will not be reviewed. If you don't run the unit tests, then you're going to lose points. If you don't include the unit tests and make sure you update your programs to cover all the previous assignments with the unit tests, you will lose points. So that's what following directions mean. So whatever you do, make sure you follow directions and you stay up with class. Every semester, a handful of people don't follow those instructions. They lose points. They're upset. But I'm just saying up front, make sure you do that. Mercifully, almost everybody does a good job of this. But if you're the kind of person that doesn't like to follow directions, probably not the class to be in, quite frankly, because it's going to cause everybody a lot of frustration. Okay, that's the end of part 2 of the overview.